Okay, solving radical equations. So we've been solving rational equations, now we're getting to radical equations. So that's like square roots and cube roots and all of that stuff. So an equation that has a variable in a radicand and has a variable with a rational exponent, that's a radical equation. So like the square root of x cubed plus 1 equals 65, that's a radical equation, okay? A radical equation in which the radical has an index of 2, that's just a square root equation, so that's like the square root of x equals 9, okay? So to move from a radical equation to an exponential equation, this isn't, I just need you guys to write this down. So if we have the square root of p, or x to the power of p, and then the d is in like the little v, that becomes x to the p over d. So whatever's in the v always goes in the denominator. Okay, so whatever's in the v goes in the denominator, it goes in the bottom. Okay, and then you can also go backwards, move backwards, like going from the right to the left. It may also be written like that second one, so it might be in parentheses the square root of x, or the I don't know how to say that, root of x to the power of p, same thing. I just want you to write those down so that you can transfer back and forth if you need to. Okay? And let's just get into this. This is how you solve a radical equation. Keep these here. I'm not going to talk through these. I think it helps you more to see them actually being solved. So let's do this. First things, we need to isolate the radical. So we have the square root of 4x plus 1 minus 5 equals 0. So I'm going to start by adding the 5 over. So I have the square root of 4x plus 1 equals 5. Now I need to get rid of that square root. To get rid of a square root, you square it. Whatever you do to one side, you have to do to the other side, so I'm going to square both sides. On the left side, I'm left with 4x plus 1. The right side, I'm left with 25. Then you can subtract that 1 over. You get 4x equals 24. Divide by 4. You get x equals 6. And then the last thing I need you to do every single time is to check your answer. So I'm just going to plug it into a calculator. So I have 4 times 6 plus 1, the square root of that, minus 5. And it does equal 0, which is what I wanted it to equal, so we're good. So that works. Okay, so you need to check these every single time just by plugging it back into your calculator. Let's look at B. So again, first thing, I'm going to subtract that 4 over. So I have the square root of 2x minus 5 equals 3. Now I'm going to square both sides. So I get 2x minus 5 equals 9. Add the 5 over, divide by 2, and you get x equals 7. Then I'm just going to double check it. So the square root of 2 times 7 minus 5 plus 4 does equal 7, so we're good. We wanted it to equal 7 because 7 was on the right side of the equal sign. Okay? Let's get into some more. So now we have it's raised to a rational exponent power. So it's raised to a power that's a fraction. We're still going to kind of do this the same way. There's a little differences here. So first, we still need to isolate the part that's raised to the fraction. So I'm going to divide both sides by 2. So I get x plus 3 to the 2/3 power equals 4. Now I need to see 2/3 times what will give me 1. Well, it's 3 over 2. You just flip that fraction. So 2/3 times 3 over 2, if you just multiply straight across, that's 6 over 6, which is 1. So now I'm going to raise both sides to the 3 over 2 power. Okay. So the left side becomes x plus 3 to the 1 power, so it's just x plus 3. And then the right side is 4 to the 3/2 power. You can put that just directly into your calculator if you want to, which is what I suggest you do. Or we can change this into an radical equation. So remember, whatever's in the denominator goes in the v, so that's just a 2, and we don't have to write it. And then inside, that's where the power goes. So 4 to the 3/2 power is the same thing as the square root of 4 to the 3rd power, which is the square root of 64, which is 8. So the right side of this equation equals 8. Then I'm just going to subtract the 3 over. You get x equals 5. Just plug it back in, And so 2 times 5 plus 3 to the 2/3 power does equal 8, so that works. We're good. Okay, let's look at example B now. Maybe. So first we're going to add the 1 over because we need to get the x plus 1 to the 3/4 power by itself. So I'm going to add that 1 over, then I'm going to divide by 5. So now I have x plus 1 to the 3/4 power equals 8. And I have to think 3/4 times what equals 1? Well, it's 4/3 because you just flip that fraction. So I'm just going to raise both sides to the 4/3 power. On the left side, you're left with x plus 1, and then 8 to the 4/3 power is 16. If you don't believe me, put it into your calculator. Okay, 8 to the 4/3 power is 16. Then you subtract the 1 over, and you get x equals 15. Plug it in to double check, so 5 times 15 plus 1 to the 3/4 power minus 1 does equal 39, so we're good, that works. Okay? We're going to skip this word problem for now, we'll come back to it later, maybe. I don't know. Okay, this one gets a little trickier because we have an x outside of our radical. Still the same, still very doable. So first, we're going to get that square root by itself. So I'm going to subtract the 3 over. So I get the square root of 5x minus 1 equals x minus 3. And I got to get rid of that square root, so I square both sides. And I'm left with 5x minus 1 equals x minus 3 squared. And x minus 3 squared is x minus 3 times x minus 3. Okay? Now, if you multiply that out, you get 5x minus 1 equals x squared minus 6x plus 9. Now, we have a squared term, we have an x term, and we have a constant, which means I need to get everything to one side, set it equal to 0 so I can solve this by factoring. So I'm going to subtract the 5 over, add the 1. So you get 0 equals x squared minus 11x plus 10. Use the x to factor that. Factors down to x minus 10, x minus 1. So then you set x minus 10 equal to 0 and x minus 1 equal to 0, x equals 10, and x equals 1. Now I need to double check both of those answers. So I'm going to start with 10. So you have the square root of 5 times 10 minus 1 plus 3, and that does equal 10. That's what I wanted it to equal, so we're good with that one. Second one, square root of 5 times 1 minus 1 plus 3, that equals 5. We needed it to equal 1, so 1 does not work. 10 is our only solution there. Okay? So when should you check for extraneous solutions? You should always check for extraneous, that's a hard word, solutions. So every single time. You need to check these every single time. There will be ones you will get wrong if you don't check them because there's very likely that there will be ones that don't work. Okay, so always check for extraneous solutions. So always check your solutions, always plug it back in. Okay, let's look at this one. So we have 2 radicals now. So I'm just going to isolate one of my radicals, and I'm going to pick the 5x plus 4 because it's bigger. So I'm going to isolate that one. So I'm going to add the square root of x over. So I have the square root of 5x plus 4 equals 4 plus the square root of x. Now I need to get rid of the square root of 5x plus 4. So I'm going to square both sides. Okay. When you square that left side, that just becomes 5x plus 4. When you square the right side, that becomes 4 plus the square root of x times 4 plus the square root of x. Looks kind of scary. It's not as bad as you think it is if you use the box. Let's just use the box here. So 4 times 4 is 16. 4 times the square root of x is 4 square roots of x. 4 times the square root of x is 4 square roots of x. And then square root of x times the square root of x is x. So if I pull all of that out, you're left with 16 plus 8 square roots of x plus x. Now I need to isolate that second radical. So I need to isolate the 8 square roots of x. So I'm going to subtract the 16 and subtract the x. So I'm left with 4x minus 12 equals 8 square roots of x. And at this point, we could go ahead and square both sides. But first I want to see, is there anything that goes into 4, 12, and 8? And there is, it's 4. So I'm going to divide all of those by 4. And I'm left with x minus 3 equals 2 square roots of x. Now I'm going to square both sides. Okay. So when you square the left side, that becomes x minus 3 times x minus 3. You square the right side. So you have to square the outside. So 2 squared is 4. And the square root of x squared is x. So that's why that's 4x. Then multiply that out. You get x squared minus 6x plus 9 equals 4x. Subtract that 4x over. So it's x squared minus 10 plus 9 equals 0. Now I'm just going to factor this using the x. So that's x minus 9. X minus 1 equals 0. So x equals 9 and x equals 1. Now, last thing you always need to do is double check that they actually work. So I'm going to plug 9 in. So I have the square root of 5 times 9 plus 4 minus the square root of 9. And that does equal 4, so that one works. We're good. I'm going to plug 1 in. So I have the square root of 5 times 1 plus 4 minus the square root of 1. That equals 2. 2 is not 4, so that one does not work. And x equals 9 is my only answer there. Okay. I want you guys to try this one. You should get x equals 8 as your final answer. Just remember, isolate the radical first. So isolate the 3x plus 1 radical first. Square both sides, and then isolate the x plus 1 radical. Square both sides again, and then you'll have to factor that down. Okay. Remember to take the quiz, and I will see you guys tomorrow.